Here we're going to go through the basic operations we use in writing algebra. We're also going to remind ourselves of some rather important ideas, concepts that we call associative properties, distributive properties, commutative properties in algebra. These mostly seem trivially obvious to us with normal arithmetic, but as we go further in our mathematics, we will not be able to take some of these for granted, so it's quite important we understand them. So let's start here by looking at various of the conventions for multiplication. When we are multiplying numbers, as we had introduced before, we will often use the multiplication sign, the x here, rather explicitly, or cross would be a better way to call it. 2 times 3 equals 6. However, when we are multiplying variables, we can use the multiplication sign, but when there's no confusion, we're going to drop it very often. So instead of writing a times b equals c with the explicit cross notation, we might simply write ab equals c. And when we see that, we know that we are implicitly putting a multiplication sign in here. When we're using parentheses and brackets, we can use them to group numbers or variables. Parentheses is the correct term for these rather bent objects here. They are kinds of brackets. These specific ones are called parentheses. So here we've got 2 times 3 plus 4, which is the same thing as 2 times 7 equals 14. The parentheses have grouped these two for us, so we do that operation first. 3 plus 4. We can also use square brackets. That will group the 3 plus 4, so we add them first to get the 7. Or we can use curly brackets. 3 plus 4 grouped to get the 7. And when used in this way, all of these, the parentheses as a form of brackets, the square brackets and the curly brackets, have got exactly the same meaning. So again, the notation, these ones here are called parentheses, are often just brackets. These are also brackets, they're square brackets, and these are curly brackets, and mathematically these all have identical meanings in this case. Now, we routinely use several properties when we're doing algebra. One of the properties is the associative property. And operations are associative if it does not matter how we group them. The word to associate means to group. So addition of numbers is associative. So we can start out by associating the a plus b over here, doing that operation first, then adding the c. Or we can do the b plus c operation first and then add that to the a. That would be associative property here. Multiplication is also similarly associative. It doesn't matter how we group these. However, not all operations are associative. For example, division of numbers is not associative. If we do 8 divided by 4 here, we get 2. And then we divide that by 2, we get 1. But if we associated this differently, we did 4 divided by 2, that would give us 2, and dividing 8 by the 2 would give us 4. So obviously, division of numbers is not an associative property. It does not have an associative property. The distributive property is a property where terms within parentheses or brackets can be distributed to remove the parentheses or brackets. So, for example, multiplication is said to be distributive over addition. So a times b plus c is the same thing as a times b plus a times c. Many other operations we can think of, however, are not distributive. For example, addition is not distributive over multiplication. So 3 plus 2 times 5 equals 13, because 2 times 5 is 10. But if I try to distribute that differently, I have 3 plus 2 here times 3 plus 5 here, that equals 40. That would be what would happen if we tried to use this kind of distributive property, but instead of saying multiplication is distributive over addition, if we tried to say that addition is distributive over multiplication, we would find that's not true. The commutative or commutative property is one that's very important to us in the quantum mechanics we're going to do. The property of commutation is where the order can be switched round, and in English a commutator is a switch. So that's what commutation means here. It means to switch things round. So addition of numbers is commutative or commutative. A plus B is the same thing as B plus A. We've swapped around the order here. Multiplication of numbers is commutative. A times B is equal to B times A. But subtraction is not commutative. 5 minus 3 is not the same thing as 3 minus 5. Now, whether or not multiplications in particular are commutative is going to be very important to us in the quantum mechanics. Obviously, they are for real numbers, but we will be using other kinds of things, for example, like matrices, where commutation does not in general hold. Division is another example that is not commutative.